All right, number 8. This one wants us to use the rational zeros theorem to find the real zeros of the polynomial. And then we're going to use the zeros factor, is there more, of f over the real numbers. So we're going to start out by listing all the possible rational zeros. Minus 37x minus 35. Okay, so I'm going to do my p divided by q, so my constant term divided by the front. So p over q would be 35 over 1. We're going to list the factors of 35, so that would be 1, 5, 7, and 35. And then on the bottom, just 1. So when we divide these, we just get 1, 5, 7, and 35, positive or negative. 1, 5, 7, 35, positive and negative of each of these numbers. Now, we want to actually find which one of these numbers are zeros. And what we're finding is, if we were to graph this, we're finding out which numbers indicate a place where this graph crosses the x-axis. That's what we're doing. Finding x-intercepts. The solutions, the zeros, that's what we're referring to. Now, this process could be quite tedious. Now, I did 3 because of your leading or your power of your polynomial. The degree is the word I'm looking for, is 3. So that tells me at most it will cross 3 times. So it's possible that 3 of these numbers will work. We have 8 to choose from, the positive ones and the negative ones. This process could be quite tedious. So I'm going to show you by hand here, and I'm also going to show you by using graphing calculator. So you look at your polynomial, you make sure you have all your terms. So we have x to the third, to the second, to the first, and 0. If we have all of our terms, nothing is missing, we don't need any zeros as placeholders. So first, I'm going to try 1. I don't know which ones work. We're just playing the guessing game. So I will use my coefficients. That would be 1, negative 1 for this one, negative 37 for this one, and then negative 35. So I'm trying out to see if positive 1 is a 0. So the process, this is synthetic division. You're going to bring down the first term, and then you multiply. 1 times 1 is 1. And then we combine, so we have to subtract because the signs are different, we get 0. And then we do 1 times 0 is 0. We combine these, we get negative 37. And then we do 1 times negative 37. And then we combine these, and that will give me a negative 72. Okay, this is not 0. Okay, so this 1 is not a factor. This number 1 is not a factor. So I would have to do the same process for negative 1, positive negative 5, positive negative 7, and positive negative 35 if possible. This process could be quite tedious, okay? But what I'm going to do is, to try to speed it up, we're going to use the calculator. We're going to graph this function. We're going to see if we can identify places where it crosses the x-axis. And then we're going to come back and only use those numbers, because it can take time depending on how many factors you have. So I'm going to clear this out. And then I'm going to do x raised to the third minus x squared minus 37x minus 35. Okay, I'm going to graph it. Okay, and I see it crosses 3 times. Let me see if I can kind of count. So this first one looks like negative 1. So I'm going to try negative 1. And then we have negative 1, -3, -4. It looks like -5. So -1, -5, and this number is positive 1, 2, 3, 4, 5, 6, 7. Okay, so from the calculator it gives you a good indication of about which ones to try. So we want to try -1, -5, and positive 7. So these are the numbers where I think it crossed from just looking at the calculator. We're going to verify it by actually computing the 0. So we're going to do synthetic division. So I'm just going to restart. If I had an eraser, I would just erase this, but I'm doing it with pen so you can see it darker. I'm going to list these numbers again, except I'm going to do synthetic division with -1. So I have 1, -1, -37, -35. Okay. And so I'm trying -1 first. So I'm going to draw my line, bring my first term straight down, and then we're going to multiply. -1 times 1 is a -1. Add these, we get -2. -1 times -2 gives me a positive 2. Combine these, that gives me a -35. And then -1 times -35 gives me a positive 35. And these are opposite, so we get 0. Okay, so this is how we know it works when we get 0 for the end. So this one checks out. Now I want to continue. I want to do -5. The beauty of synthetic division is that we don't have to start over again. If I find a 0, I can just pick up where I left off. So I can just start with these numbers as my coefficient and then put -5. So I'm going to do that. I'm going to start with -5. And I'm going to do synthetic division with these numbers. So I have one less to deal with. You still bring the first term straight down. And we multiply. -5 times 1 gives me a -5. Combine, and we get a -7. And then -5 times -7 gives me a positive 35. These are opposites. Bring it down. We get 0. So -5 also checks out. And from here, we can just pick up and use 7. We don't have to start over from the very beginning. We can just keep going every time you find a 0. So we're going to try 7. Running out of room here. Bring down the 1. And 7 times 1 is 7. Combine, we get 0. So that's it. So we got 0 for our remainder every time, and that was it. So from our calculator, we were able to look and see -1, -5, and positive 7. That will save you some work if you can pull those up and look at those. If not, you would just have to guess and try and keep going until you find the ones that work. So -1, -5, and 7. And then it says use the real zeros to factor f. Okay, so what this means when we want to factor it, we're going to take these zeros and we're going to write it in linear factors. So now that we found the numbers 1, -1, -5, and -7, we can now write this in factored form. So that is, we have x equals -1. We have x equals -5. We have x equals 7. We're going to set these equal to 0. So I have to add 1. So if I add 1 and move that over, we have x plus 1 equals 0. This is a linear factor. We have now x plus 5 equals 0. This x plus 5 is a linear factor. Subtract 7, we get x minus 7 equals 0. This is a linear factor. So if I put these together, x plus 1, x plus 5, and x minus 7, this is the factored form of the original polynomial that we got here. And if you want to take the time, you can multiply it and FOIL it out, and you can verify that these two would be equal. So this is why we're finding zeros. It helps us to get the factored form as well. So we get x plus 1, x plus 5, and then we get x minus 7.